Oh, you don't have it in front of you. How much does he get paid per hour?
40 per hour.
40 per hour. That's a great rate. Okay. And if he works 2 hours, how much does he get paid?
80.
80. And 3 hours, 120, and so on, right? So we have to turn this into a function, some sort of a function. It's linear. So we can think of it as y equals mx plus b. What does it go up by each time? 40. And that's the slope. How much does he get paid if he works 0 hours?
0.
Yeah. Now we could use the slope formula, but sometimes the table just tells you the information you need. Okay. So we go back up here. So the function is it's 40x comma. For every hour you get paid, he gets $40. Is that okay?
Yes.
Okay. Now, the next part is he gets double that rate if he works more than 32 hours. So you might think that it's 80x at first glance. Okay. But the way piecewise functions work is they have to tie in together. And we have a problem here because at 32 hours, 80 times 32 is a lot more than 40 times 32. Okay, so this is not the correct function here. So what you have to do with piecewise functions is you have to figure out, well, what's going on at the end point. Basically, how much money does he earn if he works 32 hours? So 40 times 32, if you have a calculator handy, we need one for that. But that's, it's a good wage, $1,280 a week. That's pretty good. So that's the starting point, though. You add to it the amount that you're earning for each additional hour, which is the 80, right? He's getting $80 for each additional hour.
Yes.
But here's the thing, if he works 33 hours, we want it to be 1. If he works 34 hours, we want it to be 2. And so on, right? So the way you do that, it's kind of non-obvious, is you have to subtract out the base number of hours. So if X were 33, like if you work 33 hours for a week, 33 minus 32 is 1. 80 times 1 gets you that additional 80 for that. Any questions on this so far?
No, that makes sense.
Okay. So what I'm going to do is go to the Desmos and graphing thing, and we'll look at it together here. Just need a moment to get that pulled up. I'm going to go over and share that here with you. So we start out with 40x. Okay. That's our first function. But the way Desmos works is you have to specify the window that it should graph in. So if we go 0 less than x less than or equal to 32, and if I change this window, I think we did this last time, 0 to 1280. Okay, so this is the graph. This is like, and we can check this off at various points. Like if he works 20 hours, he gets $800, and that's what you expect to see. 20 times 40 is 80. Is that okay? Clear?
Yeah. Mm-hmm.
Okay. Now, before I graph the correct one, if we had tried 80x, the problem is that 80x needs to connect in right up here. And that's one of the reasons why this didn't work. So you'll see here, if we do this 80x minus 32, that it does tie in right there at the end. But what we need to do is, again, specify the domain. We need to say this is good for x greater than 32. Like that. And you can see that they connect nicely there. Now I'm going to change the window a little bit. I mean, I don't even know what a reasonable number of hours per week is, but I'll just go to 60, and then we'll go up to like 1,000-ish. We need to go a little higher. Let's go 3,000. That looks okay to my eye. Actually, I guess we can go out a little further. Okay, so here is your graph, and just like before, I'm going to snip this in and we'll label it here, but actually we don't need that blue one. Let me undo that. So the curly braces on the left there, those are how you'd restrict the domain because you don't have the graph going all over the place. But let me snip this into the other window, and then I'll reshare that with you. All right, so here we go. New share. All right, so here is the graph. Let's let that load up. Again, that red is that first piece that we did, and the green is the second piece. So it talked about in the problem, it's you always got to go back and figure out what is it asking for. What is the appropriate domain for this function? You might want to add some words like, well, it's 0 to however many hours a person can reasonably work in a week. I mean, you've probably heard of people saying they work 60 hours or 80 hours. I mean, that's actually a lot of time. When you start subtracting out how many hours you sleep a day, you got other things going on. I mean, there's not 80 hours in a week roughly, but and then how do you know this? I think that's what they're referring to. It's like, hey, you can't work, infinite hours. You can work more than 0. We've graphed it. We got to give appropriate units though. So on the x-axis is time. We did that in X. If you don't like X, you can use T. And then we used money on the y-axis here. And you might even want to designate that point, the 32, 1280 on your graph.
Yeah.
Something like that. I think that's everything for that one. But if you have some questions or concerns, we can go through them.
It's just found that that modifier to the 80. Kind of interesting. The x minus 32.
Say that one more time.
The little modifier for the 80 per hour. Yeah, it's interesting, I guess.
Yeah, it's always this case. Like it's wherever the breakpoint is, the breakpoint between the two. Yeah. It always ends up being like this. And you may have seen those in like distance rate time problems where you had a train that started an hour later. So you did like t+1 or started an hour earlier, t-1. You subtract out the base amount basically. Okay. And as an aside, you want to be up here. Like you want to, this is the gravy. This is a great place to be when you're working. If you can get that higher rate. All right, here we go. So number 2, it says an online wholesaler sells novelty hats in bulk. The purple and leopard print hats sell for $18.50 each when you buy less than 45 hats. For orders of 45 or more, the price is $16.50 per hat. Express the total cost of the order as a function of the number of hats ordered and graph this function in an appropriate window on your paper. If your group has a budget of $760 for hats, how many hats can you purchase? So again, they're doing a nice job here of specifying the domain. They're saying, and that's what you look at first with these. You always look at the domain. They're saying less than 45 hats. So again, it's a piecewise function. If you buy less than 45 hats, you get that price. You can buy 0 hats, I suppose. But and that's a small thing, but you do want to say, you can't just say less than 45 because that means you could get negative hats and that's not even reasonable. Totally unreasonable. What is the cost per hat at that price point?
$18.50.
So it's $18.50 times X for that. Okay. Now this one follows a really similar model to the previous one, right? It has a second piece for when X is greater than or equal to 45. There's no upper bound on that because I suppose you could order as many hats as you really wanted. As many hats as resources are physically available, but it's just like the last one. You have to figure out, well, what happens at the end point? What happens when you buy 45 hats? Because that next one you should get the discount on.
Okay. So yeah.
So this one's a little awkward though, because you can't buy part of a hat,
Yeah.
which is a little weird. So we actually need to figure out how much you would pay. Sorry about that. I'm just trying to process this because I think we actually has to stop at 44 hats.
Oh, less than 40.
And then this one's good greater than 45. I'm sorry, greater than 44, but we include the 45th one is charged. That's what I'm trying to say. The 45th one is charged at the 1650, whereas the 44th is charged at the 1850. That's how I'm reading this. If you buy 44, 45 or more, it's 1650 per hat, starting with the 45th one. Is that how you read it, or do you read it differently?
I read it the same.
Okay.
45, yeah.
Because it's a little awkward. It's like, well, are they all 1650 or just the newer ones? And I tend to overthink these things because I look at them from a lot of angles. But anyway, let's figure out what 1850 times 44 is, because that will give you the how much you're paying for the first 44 fats. That's $814.
Yep.
So $814 plus. For the new hats, it's 1650, but this time you're subtracting out 44 because of that's kind of the base amount.
Yeah, the cutoff. Yeah.
Because that when you put 45 in here, it's supposed to show you that you're paying 1650 for that next hat.
Yes.
So this is your f of x. I mean, this is your cost. You can use better letters, like you could use c of x instead of f of x. You could use h instead of x if you prefer for hats. We probably somewhere should have said x is the number of hats. And usually the question tells you the variable. Okay. Do you need any more explanation on anything that I've put down here?
No.
Okay, so I'm going to jump over to the other window and graph this thing. I'm going to clear out my old graph. So yeah, it's 18.5x. And this is good when you're going from 0 less than or equal to x less than or equal to 44. Okay, so our window is okay for now. And you can see right there the endpoint. It's always good to kind of click on that endpoint, see if it matches what you think you have. So the next part of this is that 814 plus 16.5 x minus 45. Okay, and then you see the fact that it's overlapping, there's a problem there. That means that we need to restrict this to x greater than 44. And this is what I was worried about. Okay, so let me just manipulate this a little bit. Let me go to 45. And we'll go greater than or equal to 45. I knew this was going to be a problem. There it is. Okay. I don't know what to tell you. This is this problem is worded improperly. But because you can't buy half a hat.
Yeah.
But the idea here is that you're splitting it up, at the break point. So what I think is frustrating is there's this little gap right in there. You're supposed to close the gap. You're not supposed to see that when you're graphing it. So how many hats might someone reasonably purchase? I have no idea. Maybe but we know that they have a budget of $760. So we'll put that in here, and that'll maybe give us some insight. Okay. So notice that it intersects in the first function, that means they can't get the discounted price, unfortunately. So I don't know. Let's say 100 is our window. Let me just reframe this a little bit. 100 seems like a lot of hats, even in today's market. Let's go 1500. Okay. I don't know. This is probably as good as we can do here. So let's this would be one of those good ones to ask your teacher. I can't remember. Do you have a in-class part, or is it all online?
He holds like his own separate like tutoring sessions for the homework. And I'm
Okay.
holding it this Friday, so tomorrow I can go in.
Yeah, I would ask. I mean, I think I'd be really surprised if he reads it differently where there's this awkwardness right at the sort of this break.
Yeah.
And so again, this is the number of hats X and cost Y, or F of X, I guess you could put on there. And it's good to go to those office hours to they get to know you. You have a face to put with a name. It really does matter. All right, so now the couple ways to do this last part, the 760, you can obviously do it right there. Find that intersection point on the graph, which sorry, again, that's right there on the graph. But we can also do it by hand. Do you know if you need to do it by hand, or you can show it graphically?
Talking about the graph.
No, the last part there where you've got to find the intersection. We'll just do it both ways so you can see that. So 760 equals 18.5x. Divide both sides by 18.5. And you get x equals 41.1. So there's not enough to buy that 42nd hat. So you would say 41 hats can be purchased. And I guess I would change this to up here, this 44 to 45. That is how we graphed it. There's just this awkward break because you can't buy 44 and a half hats.
Yeah.
All right, I'd like to move on to number 3, if you're okay with that.
Yeah.
This one's very similar. All right. University department is planning to have a local company print custom shirts for them. The price for creating and printing the shirts is as follows. The design and setup fee is $75. So that's the one-time charge. That's the fixed, you can think of it as the fixed cost. Like if you ever gotten a gym membership, they often charge you an initial thing to join. But then you pay this amount for each shirt you buy, the first 75. But then you finally get a discount with the 76th shirt. So it's just like the last one. You get the lower price after you do that. So again, I recommend starting with your domain, which is you can purchase 0 up to 75 shirts. And then the next one is if you buy more than 76 shirts, you get the new price. So don't start with the function, start with the domain. That helps to organize your pieces, if you will. So if you're going into business, or if any of this stuff interests you, there's what's called fixed plus variable costs. And the fixed cost is like your B value in your equation. It's that initial amount that you have to pay. And then the variable cost is like whatever it goes up by each time. That's the slope. So that's where this comes from. So again, it's 75 plus, because you have to pay that for the startup. And then it's 22.5x. It's just like the last one in that regard. You pay so much. Okay, now you got to figure out what's going on at the edge point. Basically, like if you buy 75 shirts, how much do you pay? Because we need that number. That's like your new intercept, basically. So grab it. If you got a calculator, grab it. I'll do it as well. 75 plus 22.5 times 75. So that ends up being $1,762.50. And it's the 76th shirt where you get the discount. So the offset always comes from the previous point. So it's X minus 75. So when you put 76 in there, 76 minus 75 is 1. You're going to pay the new price on that next shirt over.
And then just plug in the 250 to find the last one.
Yeah, because it'll tell you it here. This one doesn't, I guess, need you to graph. So you need to give this an f of x, and then f of 250 is, like you just said, 1762.5 plus 20.5, 250 minus 75. You have a number for that?
One on the calc. Mm, 5,350.
Yes. Now, just as an aside here, have you ever purchased shirts or hats or anything like this in bulk?
No.
So if you ever do, you don't actually, like, you do care what you pay, but what you really care about is the cost per shirt. Because usually you're selling these things, like you you're buying the shirts, but you're going to sell them. So what you really care about is your average cost, or your cost per unit. So you would take that 5,350 and you would divide it by the number of shirts you're getting, which is 250. And that ends up being $21.40. Now, it doesn't ask for that. This is all just extra, but like, that's the real number you care about, is like, how much am I paying per shirt? If you and I were going into business to print custom shirts, that's what we care about. That's usually what your customer cares about. I mean, they know they're going to pay a bunch, but they want to know what it is per shirt, because they're going to sell them per shirt. All right. Any questions on that? Move on to number 4. Okay. Oh, tax problems. Okay. And this is how the tax in the United States is. It's not it's misunderstood. And this table will explain why. And these tax rates are not accurate. No matter what, these wouldn't have been accurate in, I don't know, a long time. The most people don't pay any tax up until a certain threshold, so that's true. Okay, but I think the rates, I think they're like 14, 24, and 30 something. But they're not so incremental like this. But this is a textbook problem, so that's why it's this way. But the idea is like if someone tells you that they're in the highest tax bracket like this, all that means is any income over this amount is taxed at that rate. their first $15,700 is taxed or well, I'm sorry, the first $15,700 is taxed at the 1%. The next amount of money they make between 15,700 and 37,220 is taxed at this rate. So it's kind of it's presented incorrectly. You only pay your tax rate for the money you make beyond the threshold of that bracket.
Okay.
Okay, and like, I don't know if you have an income or care, but like you will have to pay taxes at some point in your life if you haven't already, and it's kind of a painful thing.
Okay.
It really is. Okay, so the stuff in the beginning here is a lot of just setup here. It's like they they're giving you, they're telling you, what are they telling you here? Following a simplified version of the actual California state tax tables for married filing jointly up to 37,000. Okay. Okay, I see. All right, so there's a lot here. This is the state tax codes, not the federal. I was referring to the federal. These might be accurate for state tax. Very well could be. And they even say it's from California. So okay. What they're wanting you to do though is like create a piecewise function so that your input is the amount of income you made. Okay. So and then we're going to stop at this number right here. All right. So we'll go again. We'll go through this together. Not going to put you on an island here or anything, but if you make anything in California, you're going to pay a 1% tax on the first $15,700. Okay, so it's actually this number kind of is like the bracket the bracket should be more like this: 0 to $15,699. You pay 1%. That's really how the bracket should be read. And then at the next threshold, 15,700 to 3,000, and actually, I'm sorry, we need to go out to cents, 0.99 to 37,219.99. Then you pay 2% on that money. Okay, so maybe this is overwhelming. It's not meant to be, but it's a lot going on. So you pay 1% on any money made in this first threshold, and then any money you make over it gets now taxed at 2%.
Got it.
Okay, so it's like on that, when you make $15,700 or $701, that's a better example. That one extra dollar you pay 2 cents on tax instead of the previous dollar where you paid 1 cent of tax on.
Yeah.
And then it goes up from there. Okay. So the base one's usually the easiest to deal with because it's 0.01 times however much you made. Okay. But we're getting ahead of ourselves. We need to create a piecewise function here, f of x, and we need a domain. So the domain for the first one is if you make no money all the way up to $15,699.99. And then for the next one is if you make $15,700 all the way up to $337,219.99. And now we got to come up with the function. We kind of did for the first one. The first one is 0.01x.
Okay.
So that means, this function represents how much you're going to pay in taxes. For the first one, it's easier, 1% all the way up to that threshold value. So now you have to evaluate it at that threshold value, that breakpoint. So you have to go to your calculator, 0.01 times $15,699. And we're going to round because it's right on the edge there with the 15,700, but it ends up being $157 right there at the threshold. Okay. Plus, just like the previous problems, you have to subtract out that breakpoint. So that breakpoint is $15,699.99, but you pay 0.02 on anything you make over that.
Okay.
It looks like we need to graph this function. So any questions on this so far?
No, makes sense.
Okay. The tax tables really aren't that complicated after you understand this. But it is hard. You do have to, like, they don't tell you, like, if you like, let's just say you made $40,000 a year, nice round number. 4% is too much. You will not pay 4% in tax rate. You will pay a weighted average of 1 and 2 and 4%. It'll end up being closer to the one that most of your income was made at, which is 2%. So sometimes you got to be careful when people say, oh, I'm in the whatever tax rate, because it's not always true. Okay. And then that's all I'll say on that. So here's the graph here again. 0.01x, restrict the domain, 0 less than or equal, x less than or equal to $15,699.99. And so we've got a problem already with our graph because the income isn't high enough on the x-axis. The input is the amount that you're making. So I'm going to go adjust the x to person making $40,000 a year. And the y, I don't think we're going to get that high. We'll go to maybe like $500 in tax. So you can see, like, most of them, they just stop. And then you've got to add in the new one, the 157 plus 0.02 x minus 15,699.99. Again, we got to restrict the domain. 15,700 less than x less than 37,000. Go to my other window to get that number, 219.99. Okay. And there's a reasonable window there. So the edge point is right there at the end. So person making exactly $37,200 is going to pay $587 in taxes. So notice the graph gets steeper. The blue is, and this is the progressive tax rate. It means you pay a higher percentage the more you on your income as it goes up. That's why it's steeper. Okay. Than the blue line there. So let me snip this in. You can see, I mean, it's not terrible. I don't know what Arizona tax rates are. But I'm sure they're comparable. I mean, they're not like, it's not like Arizona, you pay, double this or anything. You'd probably pay a little less in Arizona if I had to guess, but income might be lower as well. So let me go back to the other screen. Okay, so this is your income in dollars, and this is your taxes in dollars. So sometimes you have the same units on each axis, depending on the problem. Any follow-up to that or any other questions?
Makes sense so far.
Okay. Just as an aside, your effective tax rate, which is what you actually pay, is the amount of tax you pay, which in this case was at the end here was 587 over your income, which was, I don't know, it was around 37,220. And like I mentioned, like it's not as steep as most people think it is. This ends up being about 1.5%. Not the full 2%. Okay, we got about 10 minutes left. I can make up problems. We can do some Alex. You'd have to share your screen for that. I don't know if you have another homework assignment you want us to look at or test prep. What can I help you with?
I got some test prep.
Okay.
Let's see if I can send that over.
They usually give you like a PDF, they give you, it's got like 100 questions in it, and they asterisk the ones that are important.
Yes. Just email it in. Or does that work best?
I'm sorry, say that again.
Should I email it?
Yeah, email or drop it in the chat. And then I'll have it for future lessons.
Okay. And send.
Okay. Do you know when your exam is?
It is, I believe, the 16th.
Okay, so a week from today. Few things I think might be important to say would be the first exam should be the easiest, which means like you should say, okay, let me do whatever I can to do well in this one, whatever that means to you. It only gets harder from here, right? Like there's not this really, should be your best effort. Okay. That's all I'll say on that. There's a ton of problems here. Do you want me to just do the ones that are asterisked? Do you want me to just start at the beginning? What would be best for you?
Well, I think let's just start with, I think, the first one.
Okay.
The domain thing, I think.
Yeah. Yeah. So I've seen these tests before. They are multiple choice. They are like these questions. They're not the same. They do, they'll change up the numbers, but they are doing their best to help you out here. Okay. So I make a joke here that it's the first math commandment is you cannot divide by 0.
Yeah.
Okay. So you look at the bottom. Top you don't care about. You have to factor the bottom. So two numbers that multiply to 4 but add up to 5, x plus 4, x plus 1. And you set those equal to 0. So you said x plus 4 equal to 0, x plus 1 equal to 0. And these are the excluded values. So you could almost do it like this, not equal to 0, because you can't divide by 0. So x cannot be -4, x cannot be -1. I got an extra 1 in there. And those are your excluded values. So it's everything except that. Would you like us to go on to number 2?
Yeah.
Okay.
Yeah, this is. Yeah, this is like the one thing I need more review on, the square roots and stuff.
Okay, sure. Yeah, so next thing here is you cannot take the square root of a negative number. So the part under the root, you set the part under the root greater than or equal to 0. So you literally set 3 plus 7x greater than or equal to 0. and you solve for x. Okay, so you subtract 3, 7x greater than or equal to -3, divide by 7, divide by 7. So x has to be greater than or equal to -3. And none of the answers, I'm sorry, -3/7, none of the answers have that form. So you have to remember how to convert from this form to interval notation. You start by putting a notation at -3/7, and you say, okay, well, which way is it? It's to the right. So it's all the numbers bigger than -3/7, but less than infinity. In interval notation, use brackets with the filled in bubbles. Parentheses always get, or infinities always get a parentheses. So you're looking for the one that matches this. And you do see that it's there. It's letter A. So just as kind of a cheat sheet here, this symbol, this symbol, this symbol, these all go together. And then the filled in bubble goes with the these other ones over here. So this is a good list to kind of remember.
Mhm. Okay. Yeah, I think I just need to remember those like, small rules.
Yes.
Okay. Got all of these.
I got time for 1 or 2 more questions.
I guess we'll do number 7.
Okay.
The first star ones. Okay.
Yeah. So some rules here. Do you know if you'll be allowed to use Desmos to graph these?
No, we are not allowed to. use those.
Okay. All right. That's too bad. Okay. So a couple things you're looking for. If you see a y squared, it's a no. Okay. So that's kind of your first rule.
Yeah, okay.
So do you see a y squared? So that's out for A. B is out. D is out. Okay.
C is also out. Right?
Say that again.
C is also out because like even squares.
So it's yes, the general rule is y to an even is no. Okay. So that's like one of the rules. There's more, but that's enough for this problem. They tend to give you it as an equation. So like 8 would not be typically found on the exam from my experience over the years working with students. But, I don't know for sure. Okay. So what you're looking for are duplicates in X. And do you see how there's duplicates here? That doesn't automatically mean they're gone. It's not a function, but it is if they go to different numbers. So see how that goes to 3100 and then
outputs for one input.
Yeah, right. But the duplication isn't enough. It's got to go somewhere different. So B is out for the same reason. And you're looking to exclude them, like this last one here, also out for the same reason. D has got a 50 and a 50. It's also out. So sometimes you can do that. I mean, that's a test prep taking strategy for that. I don't know if there's any other fast ones here. Let me just give you some advice here in the last, minute here we got. I would try the problems on your own and, see where you're struggling with. Do the 13. I think the answers are at the end.
Yeah.
You get I think it's like 25 or 30 questions in an hour. So you only get about 1 to 2 minutes per problem. So just keep that in mind. Like you've got to be able to do it fast. And, I'll certainly be available if you want to schedule another lesson between now and your exam.
For sure.
So let me stop the recording here.